Now dear student, we are going to discuss question number 2.6, and in this question we will discuss about combination of capacitors. Actually we know we have two types of combination, series combination and parallel combination. In series combination, charge on each plate of a capacitor remains same, but voltage is actually divided, or we can say V becomes V1 plus V2 plus V3. But in parallel combination we know potential difference across each plate of a capacitor remains same, but what will happen with the charge? Charge is divided, Q equal to Q1 plus Q2 plus Q3. Clear? So now we are going to discuss this question. Three capacitors, each of capacitance are connected in series. Clear? So concentrate on a screen. We can say, let's suppose here we have a capacitor, let's suppose here we have a capacitor, and let's suppose here we have a capacitor. Clear? We have total 3 capacitor. Clear? And having capacitance, this is given to you 9 microfarad. Clear? Each capacitor is having same value of capacitance. Clear? What is total capacitance of combination? Clear? So now we know in series combination value of Q remains same, but what about V? So we can say V is given by V1 plus V2 plus V3. Clear? Now let's suppose if we replace this combination by a single capacitor. Clear? And let's suppose equivalent capacitance, let's suppose I am giving with CS. Clear? So we can write like this, this is V equal to what? We can write this is Q by CS. Clear? This is Q by C1 plus Q by C2 plus Q by C3. Clear? From here we can write like this, 1 upon CS, this is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. My dear student, here we have a very easy concept to learn this formula. Actually students are always student can relate this expression with the resistance. Clear? In resistance we always find R equal to R1 plus R2 plus R3 in series, but in capacitor this becomes opposite. Clear? It means in parallel combination of resistance we find 1 upon R equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Here we are getting that combination in series. Clear? So we have just opposite. Yes. So in series combination we are having 1 upon CS equal to this one. Now we can put here values, 1 upon CS equal to 1 upon value of C1. Value of C1 we have, this is 9 microfarad, 1 plus 9, 1 plus 9 plus 1 plus 9. Clear? This should be equal to 3 by 9. Clear? So we can say value of CS, this is given by 9 by 3. Clear? And from here we can say this is equal to 3 microfarad. Clear to you? So what is total capacitance of a combination? Answer, we have 3 microfarad. Clear? Now next question is asking to you, what is potential difference across each capacitor if combination is connected to a 120 volt supply? So we can do one thing, this value we are getting 3 microfarad, and we can say this is connected with the battery, and battery is having potential difference 120 volt. Clear? So we can say this is connected with the battery. Clear? This is 120 volt. Clear to you? So can we find here value of Q? Yes or no? Yes. We can write like this, Q equal to CS into V. This is 120 into 3 into 10 to the power minus 6, and we can say this is coulomb. Clear? From here you can say this is equal to 360 into 10 to the power minus 6 coulomb. Clear? Now this is value of a charge, this is present on this capacitor, value of charge remains same. So now we can easily get value of V1, V2 and V3. Clear? So now you can write like this, V1 value we have Q1 upon C1. Q value is given 360 into 10 to the power minus 6, 10 to the power minus 6 over value of C1, this is 9 microfarad, so 9 into 10 to the power minus 6. Clear? So we can say this is equal to what? 40. So we can say this is 40 volt. Now listen carefully, each capacitor is having same capacitance, and it is the value of charge is also same. It means V1, V2, V3 this remains same, V1, V2, V3, and this is equal to 40 volt. Clear to everyone? Yes or no? So this is all about this question.